Another installment of Insomnia Math. I have invented another simple algorithm using middle school geometry that presents an interesting problem. Let's start with a grid. A blank grid. Okay, that's boring. Let's start with a square of area 1. We are going to take the perimeter of that square and use that as the area of our next square. The perimeter of a square of area 1 is 4, so our next square has area 4. One thing to note about this algorithm is that the perimeter of the square is always the smallest possible. So for our square of area 4, that is 2 times 2 and not 4 times 1. A square of area 4 has a perimeter of 8. A rectangle of area 8 has a perimeter of 12. A rectangle of area 12 has a perimeter of 14. And a rectangle of area 14 has a perimeter of 18. And a rectangle of area 18, its perimeter is also 18. And there, our algorithm stops. 18 and 16 are the two numbers where our area matches our perimeter. Along with these numbers, there is also a loop that goes between 22, 26, and 30. An area of 22 has a perimeter of 26, an area of 26 has a perimeter of 30, and an area of 30 has a perimeter of 22. Some higher numbers lead downward to 18. For example, 64 leads to 32, which leads to 24, which leads to 18. Other numbers lead into the loop. 45 leads to 28, which leads to 22, which begins the loop. There are some basic rules about how the algorithm will work. First, every output will always be an even number. The output for every step can be as small as 4 times the square root, if it's a square number. The output can be larger than the input, but only if the number is prime or semi-prime. If the output has one of the sides of size 3 or larger, it will always be smaller than the input. In general, the algorithm will push numbers down, and quite quickly. My basic conjecture is that the three outputs for this algorithm are 16, 18, and the 22, 26, 30 loop. To me, this seems obvious, but I have no idea how I would prove it. Coincidentally, this process popped into my head a few nights ago as I was trying to sleep. The next day, a relevant XKCD appeared, pointing out that difficult math problems tend to be incredibly abstract or incredibly concrete. This problem is one of the latter. It seems pretty simple and intuitive that the numbers go down quickly, but there could be another loop of numbers, perhaps somewhere around a Google or a Googleplex. Who would know? And despite being seemingly trivial and unrelated to reality, this problem is also why your blood is red and not green or blue. If that makes sense to you, say why in the comments.